Let's discuss managing complexity. There's other structures. You know about the looping structure. And the loop structure repeats a set of actions while condition remains true. There is a loop body, and those are the statements within the loop control. It's also called repetition or iteration. A condition is tested first in the most common form of the loop. Programmers call this structure a while-do loop or a while loop. And it looks like this. We continue to repeat until the condition is no or false. The while condition continues to be true. We continue to do that process until we end the while. Example, while you're hungry, take another bite of food. Determine if you still feel hungry. If you still feel hungry, take another bite of food. Determine if you still feel hungry. When you stop feeling hungry, obviously, you will exit this loop. All logic problems can be solved using selection, sequence, and iteration. Structures can be combined in an infinite number of ways. You can stack structures end to end, or you can nest them. But let's talk about stacking structures. The end structure statement indicates the end of a structure in pseudocode. So like end while indicates an end of a loop structure. End if indicates the end of an if structure in pseudocode. And it looks like this. So this is the pseudocode on the right. If condition C is true, then step D, else step E, end if. While condition F is true, step G, end while. Alright, but you can combine these structures by chaining them or nesting them. You can place a structure inside another structure. A group of statements that execute as a single unit is called a block. In Java, that's gonna look like a open and closing curly braces. This is a pseudocode showing a nested structure. We have a set of statements, a sequence, structured inside an if condition. This is a pseudocode showing a while loop, effectively, inside an if condition. This is a pseudocode showing a if condition, and then a while loop, and inside the while loop, another if-else condition. So we have a single alternative if condition, a while loop, and a dual alternative if condition, etc. Okay, so you can see how this looks here. We've taken this particular theme and we've added exact information to the flowchart. So for planting flowers this year, then buy flowers in pots. While frost is still possible, if it is over 50 degrees today, then bring potted flowers outdoors for the day, else keep potted flowers inside for the day. And we're going to end that if and in that while, plant flowers in the ground in if. So you can read through that logic. I think maybe take a pause and read through it to understand it, but that illustrates these nesting of conditions. Structured programs have the following characteristics. They include only combinations of the three basic structures, sequencing, selection, and loop. Each structure has a single entry point and single exit point. Otherwise, you end up with spaghetti code. Structures can be stacked or connected to one another only at their entry or exit points. Any structure can be nested within another structure. Now, you can prime input to a structure to effectively do a program. That means that you take an input question before the loop, and you use that value prior to starting that loop. The last step in that body gets the next and all subsequent input values. Here is a structured but non-functional flowchart, and this is why. We take in the prime value and we start running this loop, but we never actually change the prime value. And so we don't know if it's the end of the file or not. We continue in an infinite loop where it continues to calculate the answer and output the calculated answer, but we never actually get a new original number. Therefore, this is going to continue to run infinitely. All right. In this case, this loop is not structured. We have the input of the original number, and we basically have an exit point before the entry point, and this is not structured correctly. All right. In this case, we have the priming input here. We retake the priming input, and this is structured properly, and it works effectively. All right. Here, we have the input coming in at first, here, but we never check if it's the end of file or not after we bring in the original input, and therefore the program will have a problem. The EOF value will be doubled and output before the file ends. So use structured programs for clarity, professionalism, efficiency, maintenance, and modularity. Structured program is sometimes called go-to-less programming. That just means we no longer use go-to commands when we're running our code. Recognizing structure, you detect whether a flowchart or a program's logic or structured or is difficult. To recognize structure, check the flowchart segment for sequence, selection, or iteration. This is an example of a single alternative if condition. This is another example of a flowchart that is structured with the right inputs and outputs. So we can take this particular structure and we have a problem because we have two exit points that don't make sense. And yeah, we're going to keep running here. So structuring reduces a program to combinations of sequence, selection, and iteration. Structures can be nested and stacked in an infinite number of ways to maximize the efficiency of a process. When you modularize the steps of a program, the main program becomes shorter and easier to understand. If the process needs to be modified, the changes can be made in one location. We're going to spend some more time on modularization later. This is building methods for your software. And this is that dog washing program. We had the original dog washing program, and we build structures that make it work well, right? So we have one where we have the catch dog structure, but here we have an exit point, two exit points coming to the same place. This is a problem. If you see in step 3, we have both processes exiting in a different part of the main algorithm. All right, and so that's now what the pseudocode looks like for this dog catching problem. Although I'd probably make it a whole different set because you can tell that we can modularize this process here as well. All right, and here's a modularized version of the dog watching program. We have this catch dog start water method that we are calling each time we run our program. So it's a separate method we're using to run the software. We'll spend more time on method construction and modularization in future units. And that is all for this unit. I'll see you in class.